Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about compound inequalities. We're going to solve each inequality and graph its solution. So if I was given this inequality, x plus 8 is greater than or equal to 9, and x over 7 is less than or equal to 1. Okay? So let's go solve, they're separated, let's solve each inequality individually. So we're going to subtract an 8 to both sides here, leaving me with x is greater than or equal to 1, and, different than the or, multiply both sides by 7, leaving me x by itself is less than or equal to 7. Okay? So hopefully you can see this. We can see that there's going to be some overlap here where x is greater than or equal to 1 and x is less than or equal to 7. Okay? So let me graph that here. Okay? Well, if I graph this, okay, I'll start put a 0 here. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1, and negative 2. Okay. Well, we said that x is greater than or equal to 1. So we can equal 1 here, and we can shade to the right, right? Then they said x is also less than or equal to 7. So we have a closed circle at 7, and we shade to the left. Interesting. That means I can write this as one big inequality. All right? So the way I like to see it, if I flip this, instead of x is greater than or equal to 1, I wrote it as like 1, little note here, right? Same thing, 1 is less than or equal to x, right? If I wrote that like this, so if I wrote 1 is less than or equal to x, I don't need the and anymore because x then, it kind of like morphs together to this one here, x is less than or equal to 7. And so now we have 1 is less than or equal to x, which is less than or equal to 7, and that actually means the same thing that's going on here, right? Because we want to have where both parts are true, right? Where x is greater than or equal to 1 and x is less than or equal to 7. So instead of doing my double arrows here, I'm going to erase that. And I'm going to graph it as just one solution, or one graph here. Closed circle at 1, that overlaps where both those lines overlap there, and a closed circle at 7. I connect them together, and there we go. We have the graph here that represents where 1 is less than or equal to closed circle x in this range here, which is less than or equal to 7, closed circle right there. So now my graph matches my final answer, which is 1 is less than or equal to x, which is less than or equal to 7. So let's recap. We're given x plus 8 is greater than or equal to 9, and x over 7 is less than or equal to 1. I solved each one individually. I subtracted 8 to both sides, giving me x is greater than or equal to 1, and on this side here I multiply by 7, x is less than or equal to 7. I first graphed it, looking at it, saying, okay, they're going to be overlapping here, and I recognize that if that happens, I can write this, x is greater than or equal to 1, to be 1 is less than or equal to 7. 1 is less than or equal to x, same thing. So now I kind of morph them together, these two together, morph them together to make one continuous compound inequality here, where 1 is less than or equal to x, which is less than or equal to 7. To graph that, I have closed circles at 1 and 7, and x is between them. And so my graph here matches my final answer, which is 1 is less than or equal to x, which is less than or equal to 7.